Okay, it's a continuation of our video in trigonometric integrals. We'll consider this time uh, two examples. The first one is the integral of cosine to the fourth of x dx. Okay, that's our first example for today. In determining the integral of this, we will be utilizing an identity from trigonometry. We call this the half angle formula. The first one is for sine squared x, which is equal to 1 minus cosine 2x over 2, and the expression for cosine squared x, which is 1 plus cosine 2x over 2. Okay, so let's compute for the integral of this one. First thing you do is of course express this as cosine squared x, or this squared, okay, dx. The purpose of that is, for this particular expression, we need to use our half angle formula, okay? So that we have 1 plus cosine 2x over 2 quantity squared, okay, dx. And then we expand. Of course, this is 1/4. Let's just write this outside. Then the expansion of 1 plus cosine 2x quantity squared is 1 plus 2 cosine 2x plus cosine squared 2x dx. Okay, continuing, we have integral of before we evaluate the integral, let us write this first in the form so that it is integrable. We again use here the half angle formula because there is no direct integral for this one. So we can write this as 1 plus cosine 2x over 2. Sorry, this will become 4x. Okay, 4x over 2, then dx. Okay. And we now have integral of take note here, if we express this as two fractions, we'll have 1/2 and cosine 4x over 2. Then that 1/2 can be added here, so we have 3/2. Okay, then plus 2 cosine 2x, then plus cosine 4x, then dx. So let's evaluate the integral now. So 1/4 integral of 3/2 dx is of course 3/2 x plus, now this will serve as your u, no? So the du must be present. The du is 2 dx. You need to have 1/2, okay? And the integral of cosine 2x dx is equal to sine 2x. Same is true with this. Okay, your u is 4x, the du is 4 dx, but you should have 1/4. Okay, so 1/4 sine 4x, then plus c. Okay, so you can just choose to write 1/4 outside. Then you have 3/2 x plus this one is simply sine 2x, and this is plus 1/4 sine 4x, then plus c. Okay, so you have the integral of cosine to the fourth of x dx. Okay, let's move to our second example. This time we're going to compute the integral of sine squared x cosine squared. Let's make it more challenging. Let's say cosine to the fourth of x dx. Okay. So we have a case where both exponents are even. So how do we write this in the form where we can evaluate the integral easily? We'll use again the half angle formula, okay, for both of sine and cosine. Half angle formula says that sine squared x is 1 minus cosine 2x over 2, and cosine to the fourth of x can be written as cosine squared. This can be written as cosine squared x raised to 2, right? Okay, and we express this using the half angle formula. So this is 1 plus cosine 2x over 2 quantity squared and then dx. Okay, after that we simplify. Of course, this is 4, this will become 4 now, and this is 2, so you should have 1 over 8 outside. Okay, the integral of 1 minus cosine 2x, well, the expansion of this is 1 plus 2 cosine 2x plus cosine squared 2x, okay, dx. Then we're going to multiply these two expressions here. I will no longer put the computation in detail, but the product of that is equal to 1 plus, you can check later, okay, cosine 2x minus cosine squared 2x minus cosine cube 2x, okay, dx. And let's write this in more integrable form. 1 plus, so no problem with this, cosine 2x, but this one is raised to exponent 2, so again we use the half angle formula for this. Can be written as 1 plus cosine 4x, right, over 2. Then for this, no problem, but given the fact that this is odd, we should separate the factor cosine 2x, because we will reserve that for our du later, okay. And then we have 1 over 8 integral of 1 plus cosine 2x minus 1 half, okay, then minus 1 half cosine 4x. Then this one, we should write this as 1 minus sine squared 2x times cosine 2x dx, okay. Then further we have 1 plus cosine, we can combine this with this, so this will become 1 half, okay, so will become 1 half, so plus cosine 2x, then minus 1 half cosine 4x, then this one is distribute this, so you have minus cosine 2x and this will become plus sine squared 2x cosine 2x, then dx. Of course, we can remove this, and let's now evaluate the integral. Okay. Integral of 1/2 is 1/2 x, and this one is minus 1/2, but your u is 4x, so the du is 4dx. That's why we should have 1/4 here, and the integral of cosine is sine 4x, okay, plus this, your u here is sine, so your du is cosine 2x dx. That's why this will become sine cube, oh I'm sorry, your u, no, the derivative of your u is cosine 2x times the derivative of 2x, which is 2, so you have 2 cosine 2x. That's why we should have 1/2 here. Okay, then sine cube 2x, then over 3, then plus c. So this will become 1/2 x minus 1/8 sine 4x, and this will become 1/6 sine cube 2x, then plus c. So this is for the derivative of sine squared x cosine 4x dx.